We continue learning workbook page 56 with this problem, where we learn to solve a system of equations by elimination. Let's read along from the learning workbook. To solve a system of two linear equations using the elimination method, our goal is to adjust one or both equations so that when we add them together, one of the variables is eliminated. This would happen if like terms from both equations were opposites, like 3x and negative 3x. When you add opposites, you get 0. The most common way to adjust an equation to create these opposites would be to multiply both sides by the same number. Once a variable is eliminated, we solve for the other. Then we plug that solution back into either and solve for the value of the eliminated variable. Finally, we express the result as an ordered pair. Okay, so let's look at a problem that we will solve by elimination. Before we begin this problem, there's something that I'd like to say. We're going to clear the equations of fractions first. That has nothing to do with the elimination method. It's just going to make it easier for us to perform the elimination method. So what we are about to do right now is not yet the elimination method. It's just clearing fractions. When we start the elimination method, I'll let you know. All right, so let's clear some fractions here. This is equation 1. This is equation 2. Let's begin. So equation 1, we have 5/6 x plus 2/3 y equals 7. The least common denominator of 3 and 6 is 6. So we're going to multiply both sides by 6. On the left, we have to use the distributive property. On the right, we simply multiply. So on here, we're going to have 6 times 5/6. Well, think about what that means. 6 is the same as 6 over 1. These 6's are going to cancel. So what are we left with? 5x over 1, which is simply 5x. Now, before this 6 cancels, it is also distributed to the other term. And so 6 divided by 3 is 2. And 2 times 2y is 4y. So we get 5x plus 4y equals 6 times 7, which is 42. Okay, let's show this fractions math off to the side. 6 over 1 times 5/6. The 6's cancel. So we get 5 times 1, which is 5. 1 times 1, which is 1. 5 divided by 1 is 5. And then, of course, we still have this x. All right, and then the other one was 6 over 1 times 2/3. 6 divided by 3 is 2. So I can write that as 2 over 1. So we get 2 times 2, which is 4. 1 times 1, which is 1. 4 over 1, which is 4. And of course, we still have this y. So that's where the 4y comes from. All right, great. So we have now cleared equation 1 of its fractions. We're now going to repeat the same thing for equation 2. 7/12 x minus 5/6 y equals negative 2. All right, the least common denominator of 12 and 6 is 12. So we're going to multiply both sides by 12. We'll distribute just like we did before. And we'll show our fractions math just like we did before. 12 is the same as 12 over 1. So when the 12 over 1 gets distributed to multiply by the 7 over 12, here's what happens. These 12's cancel. They both become a 1. Anything times 1 is itself. Anything divided by 1 is itself. So this is just 7. And then, of course, we still have the x. So this is 7x. 12 times 5/6 is the same thing as 12 over 1 times 5/6. 12 divided by 6 is 2, which I can write as 2 over 1. 2 times 5 is 10. 1 times 1 is 1. 10 divided by 1 is 10. So I get 10 for the fractions part. It's still subtraction, and it still has a y. Multiplying at the end, we get the result 7x minus 10y equals negative 24. And this is a fractions cleared version of equation 2. All right, so there we go. We've now cleared both equations of fractions. Let's write our new system. So our new equation 1 is 5x plus 4y equals 42. Our new equation 2 is 7x minus 10y equals negative 24. We are now going to start the elimination method. So in your mind, I want you to create a very clear space and label it in your mind as the elimination method, because this is where we officially begin that method. All right, so the elimination method works like this. We want to create like term opposites. So 5x and 7x are like terms, but they're not opposites. The opposite of 5x would be negative 5x. 4y and negative 10y are like terms, but they are not opposites. We want to create opposites. Opposites have the same number but different signs. So if we look at our variables here and we ask ourselves, which of these variables is the closest to being opposites, we would conclude that the y-like terms are the closest to being opposites, because at least their signs are already different. So if we can just find a way to make the numbers match, one positive and one negative, then we'll have true opposites. So here's one method that you can use to achieve that. Whatever the number is, ignoring the sign from the bottom equation can be used to multiply the entire top equation. And whatever the number is, ignoring the sign from the top equation can be used to multiply by the entire bottom equation. And when I say multiply by the equation, what I mean is the whole equation. This 10 gets distributed to the entire left side and to the entire right side. So I would get 10 times 5x plus 4y equals 10 times 42. 50x plus 40y equals 420. Now we're going to do the same thing with this one. 4 times 7x minus 10y equals 4 times negative 24. Distributing again, 28x minus 40y equals negative 96. This is a new version of equation 1. This is a new version of equation 2. And I'd like you to notice what we've achieved. We created opposites. Positive 40y, negative 40y. Now the thing that's so important about opposites is when you add them, you get 0. So if we add those two equations together, the y terms are going to eliminate. And that's why we call this the elimination method. So let's now write the updated version of our system. We have 50x plus 40y equals 420. And we have 28x minus 40y equals negative 96. What we are now going to do is to add our two equations together. Okay, so 50x plus 28x equals 78x, not 78x squared. When you add like terms, you keep the variable part the same. 40y plus negative 40y equals 0. Those cancel. And 420 minus 96 is 324. Okay, notice what we've achieved, because we've achieved something very, very powerful and very, very important. We no longer have a y in our equation, so we can now solve for x. So we get 78x equals 324. Dividing by 78 on both sides, we get x is equal to 54/13. Okay. The greatest common factor of the numerator and the denominator is 6. So if you divide by 6 here and here, you get the reduced fraction 54/13 for x. Now, is that the end of our problem? The answer is no. Remember, we're solving systems. The solution of a system is an ordered pair, a point. It has an x and a y. So we have the x. What we don't yet have is the y. So we need to pick an equation to plug back into in order to solve for the missing variable. And there are so many equations to choose from. In fact, there are so many of the equations that we've actually erased some of them. So we need to find an equation to plug into. Let's see if we can find one of those. At one point in time in our solution, we had the equation 5x plus 4y equals 42. If you've been keeping track with your notes, you can probably find that where you've written that down somewhere. So what we're going to do is we're going to take this value of x and plug it into our equation. So we get 5 times 54/13 plus 4y equals 42. 5 is the same as 5 over 1, and 5 times 54 is 270. So 270/13 plus 4y equals 42. Once again, we find ourselves with fractions. So we clear them just as we did before. The least common denominator is 13, so we multiply both sides of our equation by 13. On the left, we have to distribute. On the right, we simply multiply. All right, when a 13 distributes to the 270 over 13, the 13s cancel, and we're left with 270. 13 times 4y is 52y. And 42 times 13 is 546. Subtract 270 on both sides. 52y is equal to 276. Divide both sides by 52. And again, reducing the fraction. We get 69/13. It seems that the greatest common factor of those two values is 4, and so when you divide the top and the bottom by 4, this is the result that we get. So now we can put all of this together. We have the value of x, we have the value of y, we just have to express it as an ordered pair. 54/13, comma, 69/13. Now I'd like to make one final comment before we call this video done. We've now learned all three methods for solving systems of equations: graphing, substitution, and elimination. They all have their advantages and disadvantages. One of the disadvantages of the graphing method is that you are left to interpret the graph to determine your final answer. So here's my question to you. Do you think the graphing method would have been an effective method for getting the correct answer to this problem? Take a look at the answer. The answer to my question is no. No one's going to look at a graph and think, I think the x-coordinate is, I don't know, 54/13. From this, we arrive at a very important conclusion. The algebraic methods, substitution and elimination, are often vastly preferred over graphing methods because graphing methods do not always work in finding exact solutions, especially when the solutions contain fractions.